Hi students, now in this video lecture we will go through corrosion of metals. Right, so by simple definition, corrosion means destruction of metals by the environment, right? Destruction of metals by chemical reaction with their environment, and this environment includes air and water vapor that is in air, oxygen, carbon dioxide and other gases and other pollutants that are present in air. So what happens is, when a metal is exposed to air, these components of air, which is water vapor, oxygen, carbon dioxide and other gases, will start attacking the surface of metal, right? And due to the chemical reactions that happens in this process, the surface of the metal will acquire a dull look, right? So you might have noticed this also, that when iron materials are placed in air, mainly in rainy season, when they are exposed to air, they will start acquiring a dull look. They will start acquiring a brown powder. You will see a formation of brown powder on the surface of iron, right, which is due to corrosion. It's a result of corrosion, right? And now, based on the activity series, all the metals, we will go through the corrosion of some important metals that are present in activity series, right? So let's first look at the metals potassium and sodium, right? So potassium and sodium, since we know these are also metals, so when they are exposed to air, right, they will also start reacting with the components of air, right? So we already know, we have studied all this already, that sodium and potassium, when exposed to air, they start reacting with, mainly they will start reacting with the water vapor that is present in air, right? And we have also studied that sodium catches fire in air because it reacts with water vapor present in air, and it will catch fire because of the hydrogen gas evolved, right? And since the reaction is exothermic, the hydrogen gas evolved will catch fire, right? And that was the reason that sodium and potassium, because of their high reactivity, they are kept under kerosene oil so that they may not come in direct contact with air, right, and start corrosion, right, and start corroding, I'm sorry. So for sodium and potassium, if we look at the common reactions, sodium will start reacting with, it will first react with oxygen and it will form sodium oxide. It will react, this sodium oxide will further react with water vapor present in air. It will form sodium hydroxide, right? And the sodium hydroxide will react with carbon dioxide, then it will form sodium carbonate. So as the reaction proceeds, you will see that different compounds will start forming, right? And because of these chemical compounds that formed as a result of corrosion, that is as a result of chemical reaction of metals with air, with the components of air, right? So metals will start getting metals will start to get corrode and they acquire a dull look, right? So basically corrosion is when these metals, right, will react with air, right, forming some chemical compounds. This is your corrosion basically, right? And now let's talk about corrosion of aluminium and zinc, right? Aluminium and zinc, when these two metals are exposed to air, they will form aluminium oxide and zinc oxide, right? So, and we'll go through one thing in a moment. We will go through the corrosion of aluminium in little detail, that when aluminium will start corroding in air, it will form its oxide, right? Aluminium will react with oxygen forming Al2O3, right? And this oxide that gets formed on the surface of aluminium metal, right, this will stick on the surface of metal. This oxide will get stick on the surface of aluminium metal, right, and will prevent metal surface from further getting corrode, right? So the further corrosion of aluminium will stop due to the formation of aluminium oxide. So this reaction would be considered as advantageous for aluminium, because formation of this oxide prevents further corrosion of aluminium. So that is why aluminium does not get corrode easily, because of the formation of this oxide layer, right? And now if we talk about lead and copper, right, lead and copper, when copper is exposed to air, slowly we will see a green deposit on copper, right? And this green deposit is due to the formation of basic carbonate, right? Because when copper, since we are doing corrosion, so copper metal will start reacting with components of air, right, and form basic copper carbonate, right? So copper will react with water vapor and carbon dioxide present in air, right, and it will form basic copper carbonate. This basic copper carbonate is green in color. This is green in color, right? Exactly same reaction is with lead. When lead is exposed to air, it will react with water vapor and carbon dioxide in air, forming lead carbonate, basic lead carbonate. This would be a white deposit, right? So it will form PbCO3 dot PbOH whole twice, right? This is basic lead carbonate and this is basic copper carbonate, right? So now let's talk about iron. When iron reacts with, iron forms, since like aluminium reacted with oxygen, right, formed aluminium oxide, similarly reaction of iron would be, iron will react with oxygen, right, and water vapor that is present in air, with X molecules of water. It will form Fe2O3 dot XH2O. This is hydrated ferric oxide, right? So this is how iron will undergo corrosion. Iron will react with atmospheric oxygen and water vapor, or we can also say that atmospheric oxygen and water vapor will start attacking the surface of iron when iron is exposed to air, forming hydrated ferric oxide. This is hydrated ferric oxide, which is brown in color, right, which is brown in color. And this ferric oxide is porous or powdery, that gets deposited on the surface of metal. If you slightly rub it with a sandpaper, this ferric oxide will fall off from the metal surface, thereby exposing the layer which is below it for further corrosion, right? So this corrosion of iron is a destructive process, or we can say it's a wasteful reaction, right? Why wasteful? Because it will keep exposing all the layers of iron, right, beneath it, because this ferric oxide, being porous in nature, will easily fall off from the metal surface, and the layer which is below it will again start reacting with the components of air, which is oxygen and water vapor, as per this reaction, right, and will again form this oxide, right, which is again porous. It will fall off, then again the layer which is below it will start reacting, right? So we say it's a wasteful reaction, right? So this is very important, right? So now, and the metals which are below, since we know that the reactivity of metals fall as we move down the series, right? So metals such as gold, platinum, these will not corrode. These would not corrode because of their very less reactivity. Because they are very less reactive, they won't react with the components of air. These metals won't react with air or any component that is present in air, right? So we say, even if gold metals, if gold or gold jewelry, even if it's exposed for thousands of years, hundred of years, it won't get corrode because of least reactive nature of gold or platinum. Same is case with platinum, right? Then we have one more metal, right? Silver. You might have seen this in your day-to-day life, or this is very, you have commonly might have seen this, that silver jewelry after a period of time will start acquiring black color, right? This happens because of this process corrosion, this silver metal will start reacting with hydrogen sulfide, which is present in very less amount in air, and it will form silver sulfide, which is black in color, right? So we write it as this silver react with hydrogen sulfide forming silver sulfide. This is black in color. So this is corrosion of silver, right? You might get question like, why silver acquire a black color after a certain period of time? So the answer would be silver will undergo corrosion when exposed to air, right, forming black silver sulfide when it reacts with hydrogen sulfide, which is present in air, right? So one important thing, since we already talked about this corrosion of iron, when we specifically talk about corrosion of iron, right, when we study corrosion of metal iron, this corrosion is known as, corrosion of iron is known as rusting, right? So we say corrosion of iron is rusting. Corrosion of iron is known as rusting, and chemically it is the rust that gets formed on the surface of iron is hydrated ferric oxide. The chemical formula is Fe2O3.XH2O. This is very important, right? So this is the chemical reaction that iron will undergo when it is exposed to air. Iron will react with oxygen and water vapor present in air forming ferric oxide and water. Ferric oxide.XH2O. This means X number of water molecules, right? So there are, this is an experiment, right? Since this is one point, air and water is necessary for corrosion of iron. Corrosion, we'll just study the corrosion of iron in little detail. Among all the metals, corrosion of iron is important, and we would be doing this in little more detail. Now for corrosion of iron, two things are necessary: air and water. Without air and water, iron won't rust, it won't undergo corrosion, right? And so for rusting of iron, these two things, air and water, is necessary for rusting or corrosion of iron. And this is an experiment that we have done, right? This is an experiment that you will see in your books, that is done to show that air and water is necessary for corrosion of iron or rusting of iron. If one of the thing, either air or water, is not present, right, is not in contact with iron, it won't undergo corrosion or it won't undergo rusting, right? So you see there are 3 test tubes, right, and in these test tubes these test tubes contain iron nails, right, because we are doing experiment to show the rusting of iron. So this test tubes contain iron nails, right? So first test tube contains air, first test tube contains water, and above water you see air, right? And the second test tube contains iron nails, right, and here we have also placed anhydrous calcium chloride, right, dry air and no water. This means that we know that anhydrous calcium chloride, what it does is it absorbs water vapor from air, right? So here we have air, but water vapor that is present in this air would be absorbed by this calcium chloride. So here in this test tube we only have dry air, it does not contain water vapor, because this water vapor present in this air would be absorbed by calcium chloride. So it contains dry air, no water. And this third test tube contains distilled water, right? Since we said air is necessary for corrosion of iron, so in the third test tube what we have done, we have taken water and we have boiled it, right? Boiled it so as to remove dissolved air and oxygen from this water, right? So it contains water but no air, since we have removed air by boiling water. And there is a layer of oil above this water, since we know that oil always float over water, so air would not dissolve in this water due to the presence of this oil. So oil will prevent air from getting dissolved in this water. So this third test tube contain water but no air. Air is removed by boiling water. So after, if we leave these 3 test tubes for some days, and after some days we will notice that iron nails that are present in all these 3 test tubes, only iron nails that are present in first test tube, this one, will get corrode or will get rust, and rest of the 2 won't get rust. That is, iron nails present in this tube and this test tube won't get rust. Only iron nails present in test tube number 1 here, that contains air as well as water, will get rust. These 2 won't get rust, because in the second one we have air but no water, and the third one we have water but no air, right? So this proves that air and water is necessary for corrosion of iron, right? So this is a simple experiment, you can go through it, right? So factors favorable for corrosion. What are the factors that will favor corrosion, right? Since we have studied that corrosion is reaction of metals with air, with the components of air, and when metals will start reacting with components of air, they will start acquiring slowly dull look, right? Why it acquires a dull look? Because of the formation of chemical compounds, right, when it reacts with air. Here, when copper undergoes corrosion, it will form basic copper carbonate, so it will acquire, we know that pure copper is pink in color or reddish brown in color, but when pure copper is exposed to air, due to corrosion, due to this reaction, copper will acquire a green color. It will also lose its shiny appearance, right? So metals, when exposed to air, they will lose their shiny appearance and will acquire a dull look due to corrosion, right? And we know that these are the chemical compounds due to which it happens. And in case of aluminium, it forms aluminium oxide. Here also the shiny appearance of aluminium will start changing into a dull look due to the formation of aluminium oxide, which sticks on the surface of aluminium. Similarly, silver also, we have seen that silver is, we know it's how shiny is silver when you purchase it new, right? But when you expose it to air, it will start becoming black, or it will start becoming, from shiny appearance, it will start giving you a dull look after some days because of corrosion, since it forms this black silver sulfide, right? So we conclude that corrosion of metals, due to corrosion of metals will start acquiring a dull look, right, because of all these reactions. So now, what are the factors that favor this corrosion of metals? First, I have mentioned reactive metals. Reactive metals, if metals are reactive, then only it will react with air, right, and form chemical compounds, and corrosion would be promoted. Since I said in the beginning that gold and platinum would not undergo corrosion. Why? Because they are not reactive metals, right? Because of their non-reactivity, these metals, gold and platinum, would not undergo corrosion, whereas reactive metals like potassium, sodium, calcium, magnesium, aluminium, all these will undergo corrosion, will get corrode in air because they are reactive in nature, right? So as you come down the series, in reactivity series, the corrosion of metals will decrease, right? So, and dissolved salts in metals, if